So, the speed of light is honestly one of the most fundamental constants in physics. In a vacuum, light travels at approximately 299,792,458 meters per second. This incredible speed, yet it really shapes our understanding of space, time, and the universe. Light's speed is so fast that, honestly, it's difficult to grasp in everyday terms. For example, light can travel around the Earth's equator about 7.5 times in just 1 second. This really emphasizes just how immense its velocity truly is. The speed of light is represented by the letter in scientific equations. This constant, plays a crucial role in Einstein's theory of relativity. It acts as the ultimate speed limit of the universe. Light does not always travel at the same speed through all materials. In mediums like water or glass, light actually slows down due to interactions with particles. However, in a vacuum, nothing can slow it down. So, scientists first began measuring the speed of light way back in the 17th century. Ole Romer, who was a Danish astronomer, was actually among the first to estimate it, using observations of Jupiter's moons. His findings really opened the door to more accurate measurements. Later on, James Bradley used something called stellar aberration to refine these measurements. By studying the apparent shift of stars due to Earth's motion, he provided further evidence that light's speed is, definitely finite. His work supported the idea that light doesn't travel instantaneously. In the 19th century, physicists like Fizeau and Foucault used rotating mirrors and gears to measure light's speed much more precisely. Their experiments, greatly improved accuracy. Eventually, laboratory measurements matched up with astronomical calculations. Today, we measure the speed of light with extraordinary precision, using laser interferometry and atomic clocks. These technologies allow for incredibly accurate measurements. In fact, the speed of light is now defined exactly, rather than being measured. The speed of light is central to Einstein's special relativity. According to this theory, nothing with mass can travel at or faster than light. As objects approach this speed, their mass effectively becomes infinite, requiring infinite energy to accelerate further. This cosmic speed limit shapes how we understand time and space. As one approaches the speed of light, time slows down, a phenomenon called time dilation. Length contraction also occurs, where distances shrink along the direction of travel. So, light's speed also determines how we perceive the universe. When we look at distant stars and galaxies, we're actually seeing them as they were in the past. The light from some stars takes millions or even billions of years to reach us. This means that, in a way, telescopes act as time machines. Observing distant galaxies allows astronomers to study the early universe. The further away an object is, the older the light we are seeing. The concept of light years, it stems from the speed of light. 1 light year is the distance light travels in 1 year, about 9.46 trillion kilometers. This unit really helps us express those vast cosmic distances. So, light's constant speed also influences the structure of causality in the universe. It makes sure that cause always comes before effect, and that, information can't travel faster than light. This is really important because it helps maintain the consistency of physical laws. Besides visible light, there are other forms of electromagnetic radiation that travel at the same speed in a vacuum. This includes things like radio waves, microwaves, infrared, ultraviolet, X-rays, and gamma rays. All of these forms, they share the same fundamental speed. Light speed actually plays a key role in technologies like GPS. GPS satellites have to account for time dilation effects because of their speed and their position relative to Earth. Without making these corrections, navigation would end up being, highly inaccurate. Communication with spacecraft also depends on the speed of light. For probes exploring distant planets, signals can actually take minutes or even hours to reach Earth. This delay, it really complicates real-time control and means we need to rely on autonomous systems. The finite speed of light also affects astronomy in other ways. Light from distant objects can actually be bent by gravity, which is a phenomenon called gravitational lensing. This effect, allows us to observe parts of the universe that would otherwise stay hidden. In quantum physics, light shows both wave and particle properties. Photons, which are the particles of light, still have to obey the universal speed limit. Their behavior, honestly, continues to puzzle and inspire physicists all over the world. So scientists have explored whether it's possible to exceed light speed. Concepts like tachyons, which are these hypothetical faster-than-light particles, and, warp drives, exist in theory. However, there's no experimental evidence supporting these ideas just yet. The speed of light also, it really influences black holes. At the event horizon, even light cannot escape the gravitational pull. This boundary marks the point of no return in a black hole. Despite its constancy, some speculative theories suggest light's speed might have varied in the early universe. If true, this could explain certain cosmological puzzles, but so far these remain unproven hypotheses. Light's speed is fundamental to the equations that describe electromagnetism. Maxwell's equations predict that electromagnetic waves travel at the speed of light. This unification of light and electromagnetism was a major breakthrough in physics. The speed of light continues to be a cornerstone of modern science. From theoretical physics to practical technology, it touches countless aspects of our lives. Its constancy allows for the precision and predictability of many systems we rely on. In conclusion, the speed of light is much more than a number. It's a key to understanding reality. Its role spans from the smallest particles to the largest cosmic structures. As we continue to explore the universe, light speed remains both a limit and a guide.